Okay, so when we left off, we were on number 5 of the free fall sheet. We were just starting it, and it says a pitcher throws a baseball straight up with an initial speed of 27 meters per second up. Its acceleration is going to be 9.81 meters per second squared down. And the question wants to know how long does it take it to reach its highest point. You're looking for delta t, and that's for part A. And when it reaches its highest point, it means its VF is 0. So what equation do you know for part A that has an A, a delta t, a VI, and a VF? Should be your 10th grade equation, VF minus VI over delta t, and you're searching for delta t, which is really going to be the time up, right? We're not looking for the whole time this time. So multiply both sides by delta t, divide both sides by A, VF minus VI over A. So delta t, it's going to go up until it stops, so that'll be, if you want to write it in, you can 0, or just minus 27 meters per second, and that goes in as a positive because it's going up. And the A is 9.8 meters per second squared, but it goes in as a negative because it's going down. And so in the end, you get a positive time for the time it takes to go up, and positive time is always a good thing, 2.752 seconds. Doesn't ask for how long it's in the air, just how long does it take the ball to reach its highest point. Part B wants to know how high does it rise. So now you're looking for delta D, and you have VF, VI, A, and delta T. I'd probably use the first thing and avoid my delta T just in case I screwed up, so I'd probably go VF squared equals VI squared plus 2A delta D and rearrange for delta D. So bring the VI over, so it'll be VF squared minus VI squared, and then you would divide both sides by the 2A. So you would have delta D is equal to VF squared minus VI squared over 2A. The VF is 0. The VI is 27, so it'll be minus 27 meters per second, and just the 27 gets squared, not the minus, over 2 times negative 9.81 meters per second squared. And when you do this, you get a delta D of 37.16 meters, works out to be positive, which means up. Okay, so those are the free fall questions I asked you to do. I also asked you to go back to the displacement, velocity, and acceleration problems. You had done up to number 6 on those, and I asked you to try numbers 7 to 12, so the rest of the front side. So number 7 says a car initially sliding backwards down a hill, so VI is negative 25 kilometers per hour because it's sliding backwards. Lost the question. The driver guns the car. By the time the car's velocity, V final, is, so this one's negative and this one's positive, 35 kilometers per hour. It is 3.2 meters, delta D, 3.2 meters positive. From its starting point, assume the car was uniformly accelerated. What is the acceleration in meters per second? Okay, so you need to switch these from kilometers per hour to meters per second, and to do that, you would get rid of the kilometers first. It goes on the bottom, meters on the top. So 1,000 meters in 1 kilometer, because kilometer is bigger. And then you want to get rid of the hours, which is on the bottom. So you have to put it on the top, seconds on the bottom, 1 hour and 3,600 seconds. And when you do this, you should get 6.94 with the 4 repeating meters per second. And it's negative. Have to do the same thing with the 35. So again, kilometers on the bottom, meters on the top, 1 kilometer, 1,000 meters, hours on the top, seconds on the bottom, 1 hour, 3,600 seconds, and you get 9.72 repeating meters per second. Okay, and then 7 wants you to find the acceleration. Well, you have VF, VI, and delta D, and you're looking for A. So I would use VF squared is equal to VI squared plus 2A delta D. Get the A alone, so take the VI over. VF squared minus VI squared is equal to 2A delta D, and now divide both sides by delta D. So A equals VF squared minus VI squared over 2 delta D. VF was the 9.72 repeating meters per second squared minus a negative 6.94 with the 4 repeating meters per second squared over 2 times 3.2 meters. And when you do this, you should get an A of 7.233 meters per second squared. Okay, number 7. Number 8 says highway safety engineers build soft barriers so that cars hitting them will slow down at a safe rate. As mentioned above, a person wearing a seatbelt can withstand an acceleration of negative 300 meters per second squared, negative meaning opposite direction of motion. How thick should a barrier be? You're looking for delta D. To safely stop, VF must be 0. To safely stop a car that hits a barrier going VI 110 kilometers per hour. Again, you need to switch this 110, and when you do, you get it to be 30.5 repeating meters per second. What equation are you going to use? If you have A, delta D, VF, and VI, exactly the same one we did use before, VF squared equals VI squared plus 2A delta D. This time you're looking for delta D, subtract VI from both sides, and divide by 2A. So you get delta D is equal to VF squared minus VI squared over 2A. VF is 0 though, so it'll be equal to subtract 30.5 repeating, and don't clear that, leave the repeating in your calculator and square it, divided by 2 times negative 300 meters per second squared. The negatives are going to cancel each other out, and when you do this, you should get 1.556 meters for number 8. Number 9 says a baseball pitcher throws a fastball at a speed of 44 meters per second. And I didn't write F or I there because I have to read further to figure out which it is. The acceleration of the ball occurs while the pitcher holds the ball in his hand and moves it through an almost straight line of 0.35 meters. 3.5 meters. Calculate the acceleration. So this is the speed when he lets it go. This has to be his VF. What's the speed before he starts to pitch it? You hold it in your hand and then you move it, right? So here's the pitcher. And he holds it back here and he steps and then he releases it up here. The back here before he moves it, it should be 0. So what equation are you going to use if you have VF, VI, A, and delta D? Should be VF squared again is equal to VI squared plus 2A delta D. The VI is 0 and you're rearranging for A, so divide both sides by 2 delta D. So 44 meters per second squared divided by 2 times 3.5 meters. A is equal to 276.57 meters per second squared. Now you might think that seems like a lot, but remember that's an acceleration, not a speed. It's not going this fast. It's changing its speed at this rate. But he wouldn't be doing this over the course of a second. It'd be a lot shorter time interval for when he holds the ball back here, steps, and releases it. So it's not like the ball is going to end up with this velocity. It's the rate of the acceleration. Next video, we'll do the rest.